Good day, I am Janine Cayabyab from BSE 3 Block 1, and I will discuss about the different parts of the microscope. First, what is microscope? A microscope is an instrument that can be used to observe small objects, even cells. The image of an object is magnified through at least one lens in the microscope. This lens bends light toward the eye and makes an object appear larger than actually it is. The history of microscope. In the late 16th century, several Dutch lens makers designed devices that magnified objects. But in 1609, Galileo Galilei perfected the first device known as a microscope. So here are the parts of microscope. First, the eyepiece, also known as the ocular. This is the part used to look through the microscope. It's found at the top of the microscope. Its standard magnification is 10 times, with an optional eyepiece having magnifications from 5 times to 30 times. The eyepiece, or ocular, magnifies the primary image produced by the objective. The eye can use the full resolution capability of the object. The microscope produces a virtual image of the specimen at the point of most distinct vision, generally 250 meters from the eye. The eyepiece tube. It's the eyepiece holder. It carries the eyepiece just above the objective lens. In some microscopes, such as the binocular, the eyepiece tube is flexible and can be rotated for maximum visualization, for variance and distance. For monocular microscope, they are non-flexible. Binocular microscope heads typically incorporate a diopter adjustment ring that allows for the possible inconsistencies of our eyesight in our both eyes. Objective lenses. These are the major lenses used for specimen visualization. They have a magnification power of 40 times 100. There are about 1 to 4 objective lenses placed on one microscope. In that some are rear facing and others face forward. Each lens has its own magnification power. This part of the microscope is needed to produce the base magnification. The nosepiece, also known as the revolving turret. It holds the objective lenses and it is movable, hence it can revolve the objective lenses depending on the magnification power of the lens. The revolving nosepiece is an important part of a standard optical microscope, used in classroom and labs. The optical microscope is the most popular form of microscope due to its low cost relative to the other types of microscope, as well as its simplicity. The adjustment knob. These are knobs that are used to focus the microscope. There are two types of adjustment knobs. These are fine adjustment knobs and coarse adjustment knobs. The coarse adjustment knob, located on the arm of the microscope, moves the stage up and down to bring the specimen into focus. The gearing mechanism of the adjustment produces a large vertical movement of the stage with only a partial revolutions of the knob, while fine adjustment knob is a part of the microscope that is used for focusing finer details and a specimen being viewed. The stage. This is the section on which the specimen is placed for viewing. They have stage clips that hold the specimen slides in place. The most common stage is a mechanical stage, which allows the control of the slides by moving the slides using the mechanical knobs on the stage instead of moving it manually. The stage of a microscope is an aluminum of iron platform where the specimen, usually on a glass side, is raised or lowered for observation under the microscope. Aperture. This is a hole on the microscope stage through which the transmitted light from the source reaches the stage. Microscopic Illuminator. This is the microscope light source located at the base. It is used instead of mirror It captures light from an external source of a low voltage at about 100 voltage. The illumination system of the standard optical microscope is designed to transmit light through a translucent objective for viewing. Typically, the condenser focuses the image of the light source directly onto the plane of the specimen, a technique called critical illumination. Condenser. These are lenses that are used to collect and focus light from the illuminator into the specimen. They are found under the stage next to the diaphragm of the microscope. They play a major role in ensuring clear, sharp images are produced with the high magnifications of 400 times and above. The higher the magnifications of the condenser, the more the image clarity. More sophisticated microscopes come from an Abbey Condenser that has a high magnifications of about 1,000 times. The diaphragm. It's also known as the iris. It's found under the stage of the microscope, and its primary role is to control the amount of light that reaches the specimen. It's an adjustable apparatus, hence controlling the light intensity of the size of the beam of light that gets to the specimen. For high-quality microscope, the diaphragm comes attached with an Abbey condenser, and combined they are able to control the light focus and light intensity that reaches the specimen. The Abi Condenser. This is a condenser specially designed on high-quality microscope, which makes the condenser to be movable and allows very high magnifications of above 400 times. High-quality microscope normally have a high numerical aperture than objective lenses. An Abi condenser is a component of a microscope. It was invented by Ernest Carl Abi in 1870. The Abi condenser is mounted below the stage of the microscope and concentrates and controls the light that passes through the specimen and enters the objective. And lastly, the rack stop. It controls how far the stages should go, preventing the objective lens from getting too close to the specimen slide, which may damage the specimen. It is responsible for preventing the specimen slide from coming too far up and hit the objective lens. And that are the parts of a microscope. Thank you so much.